Hi everyone, this is day 1, CIS-125. It's 8/29/16, and we met this morning from 8 until 9:30, and we covered a variety of things. I went over there on Mr. Dirksen. We had most people logged in, if not close to all of them. And then we filled out some cards, their name, the date, career aspirations, hobby, and then on the back of the card, any learning concerns that I need to be aware of. Introduction to programming logic. We're emphasizing the term logic with language, and the language we're using is Python. This little section up here, computer science circles, University of Waterloo. Anyway, there is a link under the skills part in the second module, and that link will take you there, and when you sign up you need to list me, this is all one word, as your guru. And we're going to take a look at that Wednesday, first thing when we get to class. So today we did some background work. We talked about PCs or any computing device. We talked about they all have a processor and they all have memory, and then in a lot of cases we have storage. Okay, now this here might represent a hard drive. And there could be other types of storage where we store things permanently. Memory is where we work on the software that's in memory, or we have storage locations in memory that hold information for us. For example, you could have, let's say you have Windows operating system loaded. You have a word processing package in there, and you're typing in a document. All those things are in memory. That document's being stored somewhere. Maybe variables isn't a real clear term for that, but it's being stored somewhere in memory. The work is being done by this process of going from here up to here, and then from here back to here. We send an instruction, gets processed, sends the results back. We may or may not see some of that output. The input is us communicating, let's say, on the keyboard. In terms of programming, we mentioned these two. It seemed like a lot of students understand the term user interface, how we interface. Are we using a mouse? Are we using touchscreen now? It's extremely popular. But I didn't have anybody know what this stood for right offhand. User experience. This is key, what kind of experience the user has with the device. And that comes from the design of the software. The design of the software. And we're going to talk about software design a lot in this particular course. A couple other items here. We talked about the arithmetic logic unit, where the work is done in the computer, and registers are high-speed staging areas in the processor so it can do this work. Alright. We also mentioned millions of instructions per second. MIPS, M-I-P-S. And we talked a little bit about clock speed and so forth. Out of this, the key thing to understand, we're processing what's in memory, and the processor is doing that work, and it's moving on the electronic bus to and from the processor. Okay? And then we write code, let's say, to add up a couple numbers. Those numbers typically are stored in locations called variables in memory. We'll look at that a little more technically as we go along. All right, next slide. Here we talked about we have program design. Once we get a program designed, okay, then we can actually start developing the source code. We develop the source code in some particular programming language. Once we get that created, then it is either interpreted or compiled. If it's compiled, it becomes an object code. We link in other libraries, other information, other code, and then we can create an executable. The compiler compiles it to be an executable for a particular operating system. So you can compile it for Windows, so to speak, or you can compile it for Linux. What we're going to do in class is we're going to go from the interpreter mode right on down to running the program. We're not going to compile it into an executable. This is way handier when learning, because you can see the code run right away. You don't have to wait for the compiling of the code each time you want to check it. Okay? Then you see the syntax errors right away too. Now, this part of the diagram, right here, I'll just mention briefly, Canvas is hosted off-site, somewhere in the cloud. Then our connection to Canvas is through, they have an internet service provider, and the college connects into an internet service provider. We use the Iowa Communications Network. Then later on, you'll learn that from home, you connect in to some ISP, probably not the same one as Canvas, which then is going to allow you to communicate here and over here. So here's the big picture. We have in the labs at NIACC, we have this. So really it's like in our IT area, we have labs and access, and that's a variety of rooms, 215, 216, 217 in McAllister, and PC 229. All are in this particular local area network. Now the college includes a whole bunch of stuff. Okay, so the whole campus, from here on, all the different locations of campus are that network. So we're kind of inclusive. So we have our access out to the ISP, and then if you're somewhere else in campus, you would come through this way and get out. Or you would communicate on campus. All right. So that's the big picture. So when we're communicating to Canvas, we're actually leaving NIACC and going to them somewhere in the cloud, and then the information's coming back. It's not stored on campus. Angel was, if you were here last year, if you used Angel at all last year. And that's it for the first day. What the students are doing is they're going through the materials in Canvas, the first couple modules, and they'll get started on computing circles, and we'll look at that some more on the next session. That is it.